What time is it? Math o'clock. Today we're dealing with linear systems and how we can use them to solve real world problems. And we're going to solve them using substitution and elimination. Okay, the two methods that we learned other than graphing. Okay, so take 30 seconds, maybe a little bit less than 30 seconds, and copy down this objective. Get set. Start to wrap up. Okay, so let's dive straight into a problem where we can see how linear systems of linear equations can actually be used. Okay. To raise money for new soccer uniforms, the SGA, the Student Government Association, sells check t-shirts. Okay, so short sleeve t-shirts cost $5 each to make, and they're sold for $8 each. They cost $5 each to make and are sold for $8 each. Okay, long sleeve t-shirts, they cost $7 each to make, and they're sold for $12 each. So once again, we're making t-shirts. Short sleeve shirts cost $5 each to make. Okay, and they're sold for $8 each. Okay, long sleeve shirts cost $7 each to make, and they're sold for $12 each. Okay, so hopefully you've got that information down. Take a second. Okay, start to wrap up. Now, I haven't given you a problem yet. Here it is. The school spends a total of $2,500, $2,500 on the t-shirts, that's to make them, and they sell all of the t-shirts for $4,200. So they spent $2,500 to make them, and they sold all of the t-shirts for a total of $4,200. Okay, so the question is, how many of each type of shirt are sold? Go ahead, take a little bit less than 30 seconds to copy this down as well. Start to wrap up. Okay, so when we're tackling a problem like this, where it seems clear that we're going to have to write some equations, it's helpful to think about what numbers we've been given in the problem and what numbers we haven't been given, what numbers we're being asked to find out. Okay, so in this situation, let's see, we were given the cost of making each short sleeve. Okay, and that was actually $5. That's $5 to make each short sleeve. We were given also the cost of making each long sleeve. Okay, and if you recall, that was $7 each to make. Okay, we were also told the total amount of money that the school spent to make the t-shirts. So we'll say the total cost to make the shirts. And that was $2,500. Okay. Now let's see. In all this, we don't actually know, we haven't been told how many shirts, how many of each type of shirt we bought. So how many short sleeve shirts were bought. and how many long sleeve shirts are bought. Before we get there, let's finish the other information we do know. Okay, we were told that short sleeve shirts are sold. Okay, so let's say short sleeve shirts are sold for $8 each. Long sleeve shirts are sold for $12 each. And the total income from selling these shirts was $4,200. Okay, so that's the information we've been given. Now, the numbers we don't actually know, like we said before, we don't actually know the number of short sleeve shirts. And we don't know the number of long sleeve shirts sold. In fact, that's what the question is asking us to find. Okay, so in this case, I think it makes a lot of sense to use variables to represent these numbers right now while we don't know what they are. Okay, so for the number of short sleeve shirts sold, let's use X. And for the number of long sleeve shirts sold, let's use Y. If you wanted, you could also use S for short sleeves and L for long sleeves. I'm going to use X and Y, but if you chose to use S and L, that's fine too. Okay. So we know the cost to make a short sleeve, the cost to make a long sleeve, the total cost for making all the shirts. We know how much we sold each short sleeve for, how much we sold each long sleeve for, and the total income from selling the shirts. We're trying to find out the number of each type sold. That's X and Y. Okay. So, the smart play here is first to make verbal models for the situation. Okay, so what we should be thinking is, we'll look, the short sleeve cost times the number of short sleeves okay, well, plus the long sleeve cost times the number of long sleeves. If it helps, we can put these in parentheses. Equals the total cost. Okay, we did that for the cost. We can also do it for the revenue or the income. Okay, the short sleeve cost, short sleeve revenue, that's all the money they made, or the amount of money they make for each short sleeve shirt they sell, times the number of short sleeves they sold. Okay, and if we add the same amount for the long sleeves, so the long sleeve revenue times the number of long sleeves, we'd get the total revenue. Okay, now we have these numbers. That's the thing here. Okay. The short sleeve cost, well, we know that from before. Check your notes for how much that cost. Each short sleeve shirt cost $5. Okay, the number of short sleeves, we don't know. So we'll leave that as X, so 5 times X. Okay. The cost of each long sleeve shirt, okay, well, we knew that as well. That was $8 for each long sleeve shirt. But again, we don't know how many long sleeve shirts were sold. So again, we'll leave that as Y. And that equals a total cost of, let's see, $2,500. Okay. Now, short sleeve revenue, question is how much did we actually earn from selling each short sleeve shirt? And that number was $8 for each short sleeve shirt. But we don't know how many short sleeves we sold, so that stays as X for right now, plus the long sleeve revenue, which was $12 per shirt, times the number of shirts we sold. Okay. And the total revenue from all these sales was $4,200. Okay, so at this point, we have our two systems of equations. Take 30 seconds, make sure you have this down. These are verbal models for the situation. Okay, so as a last step before we solve, let's actually write that whole system of equations. Okay, just one more time, nice and neat. 5x plus 8y equals 2,500, and 8x plus 12y equals 4,200. That's the system we're going to solve. Now, after you've written that system of equations, okay, the question is, how exactly do you want to solve it? Okay, and you can solve it using pretty much the method of your choice unless I ask you to solve it in a specific way. So the big question students often have is, should I use elimination or should I use substitution? Okay, and this is really a matter of personal preference. Do what you want to do. The strategy I follow, and this is what I think makes sense, okay, if I see that one of the variables has a coefficient of 1 or -1, I tend to use substitution there. Okay, I use substitution when one of the variables has a coefficient of 1 or -1. Other than that, I typically use elimination. So let's check this system that we're looking at. 5x plus 7y equals 2,500, and 8x plus 12y equals 4,200. Look, none of the coefficients, 5, 7, 8, and 12, none of the coefficients are 1 or -1. So in this situation, I want to use elimination. So let's go ahead and do that together. Our system is, let's see, 5x plus 7y equals 2,500, and 8x plus 12y equals 4,200. Okay, now if you remember, the goal of elimination, the way elimination works, is you have to get one of the variables so that the coefficients differ only in sign. Okay, so right now, look, 5x and 8x, 5 and 8, they don't differ in sign, first of all. They're both positive, so that won't work. But they also, right now, they're not the same absolute value, right? This is 5, this is 8. What we're looking for is to get this to be the same number but different signs. Same with the y's. So what we're going to have to do is multiply both of these equations by something in order to get these coefficients to differ only in sign. So we could do that either for x or for y. I'm going to choose to do it for x. So here's the idea. The question we have to ask is, what would I multiply this top equation by in order to get it into something that would have a coefficient that was the only different in sign from the bottom coefficient? Okay, and my strategy here is I want to get both 8x and 5x. I want to turn those coefficients into positive 40 and negative 40. Okay, because I see 8 times 5 is 40, 5 times 8 is also 40. So what I'll do is I'll multiply 5 times, let's see, how about we multiply 5x plus 7y equals 2,500 times negative 8. Okay, and we'll multiply 8x plus 12y equals 4,200 by 5. Okay. And this gives us the resultant equations. Okay, let's see. Negative 8 times 5x is negative 40x. Negative 8 times 7y, okay, negative 8 times 7y is negative 56y. And negative 8 times 2,500, we can use the calculator for this. Negative 8 times 2,500 is negative 20,000. Okay, let's see. 5 times 8x is going to give us 40x. 5 times 12y is going to be plus 60y. And 5 times 4,200, 5 times 4,200, that's going to be 21,000. Okay, so this is our new system of equations. And as you can see, for the x's, these coefficients differ in sign only. We have negative 40 here and positive 40 here. Now at this point, we want to add these two equations together. We want to add these two equations together. So let's see. Negative 40x plus 40x. Okay, well, that'll cancel out for us. Negative 56y plus 60y. Okay, well, that leaves 4y. And negative 20,000 plus 1,000. Okay, that's the same as 21,000 minus 20,000. That leaves us with 1,000. Last step is to isolate this y. We'll divide both sides by 4. We end up with y equals 1,000 times 4. That's 250. Okay, so that's one answer we've arrived at. Y is 250. Okay. Next step is to go ahead and plug that back in to one of the original equations. Okay, so if we start with 5x plus 7y equals 2,500, we want to plug y equals 250 in. So this becomes 5x plus 7 times 250 equals 2,500. Okay. Now let's simplify. This will be 5x plus, bust out the calculator, 7 times 250, 1,750. So 5x plus 1,750 equals 2,500. Okay, well now we have to undo this plus 1,750, so we'll subtract 1,750 from both sides. Okay, on the left-hand side we have 5x, and on the right-hand side we have 2,500 minus 1,750, which is 750. Final step, to divide both sides by 5, x is, I'll break out my calculator, x is 150. Okay, so as always, we like to state our answer in an ordered pair. Here, x is 150 and y is 250. Okay. But we were trying to answer a question that somebody asked us, like an actual word problem. So let's give our answer as well in the context of, what the word problem meant. So if you all remember, x, this variable, stood for the number of short sleeve shirts that were sold, and y stood for the number of long sleeve shirts that were sold. Okay, so what I would do now is I would state my answer in a sentence. So the Czech SGA sold 150 short sleeve shirts and 250 long sleeve shirts. And then we're all set. Okay. So now I have one more question. I'm not going to show you the answer here, but I'm going to leave it for you to work on. What if instead the SGA spends $3,715 on the shirts and sells them for $6,160? Okay, in this case, how many of each type are sold? Think about what you'd have to change, what would be different, and then go ahead and solve it. Okay, write a new system of equations that will deal with this change to the situation. Okay, so with that said, go for it, and let's tackle this problem set, answer some questions. Game on.